June 2018, question 4b. We're to solve we're to solve the inequality 3x minus 1 is less than 11. Alright, so we have 3x minus 1 is less than 11. So the steps we take to solve an inequality are identical to the steps you would take um, to solve an equation, but with one major exception. The exception is if we multiply or divide both sides of an inequality by a negative number, we must change the inequality sign. That's an exception. Additionally, if you turn around an inequality, you must also change the inequality sign. All right, you'll see that because I think this question requires that knowledge. All right, so here, therefore, 3x would be what? Less than 11 plus 1. So negative 1 goes over and become positive 1. So therefore, 3x would be less than 12. Then I'm going to divide both sides by 3. So therefore, I'm going to have x is less than 4. That would be the solution of inequality A. Inequality B, here we have 3 is less than or equal to 3x minus 1. So therefore, 2 plus 1 is less than or equal to 3x. Therefore, 3 is less than or equal to 3x. I'm going to divide both sides by 3. Alright, so now I'm going to have 1 is less than or equal to x. So if 1 is less than x, it means therefore that x is greater than or equal to 1 is my solution. So it is sort of like if someone says to you 3, that this reads 3 is less than 4, but that is if you read it from left to right. But if you read it from right to left, it would say 4 is greater than 3. Both inequalities are the same. So it's sort of like a turnaround inequality, or reading inequality from the following side, from the next side. Or you could say one side of the inequality is always larger than the other. So if the left hand side is less than the right hand side, it means that the right hand side is greater than the left hand side. Alright, so if 1 is less than x, x is greater than 1. Alright, so x is greater than or equal to 1 is the solution. You can erase this. I hope this made some sense to you. If you turn around an inequality, you must, so that you can get the x over the left hand side, you must change that sign. Alright, the last part of the question, it says, represent the solution of 2 is less than or equal to 3x minus 1 is less than 11 on the number line shown below. Alright, the first thing, 3x minus 1 is less than or equal to 11 and is greater than or equal to 2 is actually two inequalities in one. Alright, and this inequality is right from in the middle, so let's read it this side. So the two inequalities are 3x minus 1 is less than 11, and the next inequality, read it this way, and that is going to be 3x minus 1 is greater than 2. Well, that's how it should be read, or let's just keep it the way it was. All right, and I'm saying that for a particular reason. So this is the right hand side, and the left hand side is 2 is less than or equal to 3x minus 1. So this is left hand side. So what we should observe is that this is two inequalities in one. Um, and the two inequalities that make up this one inequality are inequalities that we have solved already. All right. The solution for the left hand side is x is less than 4. So the solution over here is x is less than 4, and the solution for over here is x is greater than or equal to 1. All right. So um, I'm at 1. I'm gonna draw a circle and I'm gonna shade it. The circle is indicating that um, x is equal to 1 is a possible solution. At 4, I'm going to draw a circle. All right, and I'm going to leave it unshaded, indicating that x cannot be 4. X is less than 4, it can't be 4. All right, and so the region that satisfies this inequality is right here. All right, and here x is less than 4 but greater than or equal to. X is less than 4 but greater than or equal to 1. All right, that's the solution. The inequality was actually two inequalities in one. It's two inequalities that we have solved already. And so all we needed to do was to represent the information on the number line, which we have. Um, the shaded circle is indicating that x can be equal to 1 because x is what? Greater than or equal to 1. And the unshaded circle is indicated that x cannot be 4, it is less than 4, but it's never ever 4. All right.